From the time more than 35 years ago when Lord Rutherford discovered that nitrogen could be transformed into oxygen by bombardment with swiftly moving helium nuclei, the alpha rays from radium, scientists have been seeking ways to accelerate various atomic particles to very high speeds for nuclear investigations. In the 1920s, the first particle accelerators were simply high voltage, high vacuum discharge tubes. Well, now in those days, it was found that perhaps such a particle accelerator would only be able to produce 1 or 2 million volt accelerated particles, and it was necessary to consider other means of reaching much higher energies, tens of millions of volts or hundreds of millions of volts. Well, now every child knows that in a swing, one can reach a high swinging velocity either by one big push, as in the high voltage accelerator, or by a succession of small pushes, pumping up in a swing. Well, the cyclotron, which was invented in 1929, makes use of this second principle of giving particles successive pushes in time with their oscillatory motion. Now here we have a mechanical model of the cyclotron which perhaps might be helpful in understanding how it works. There are two semicircular electrodes in the vacuum chamber of the cyclotron which, so to speak, move up and down in potential. Here we have two plates that move up and down in potential, and the particles are generated here at the center, so if they start here and this is up and this half is down, they will go across downhill and pick up energy. Now in the cyclotron, the particles are caused to go in their circles by a powerful magnetic field. A large magnet is used. And the up and down hill is provided by an oscillating electric field, electric voltage, a radio frequency voltage that goes in step with the circulation of the particles. They go around hundreds of times, and therefore they acquire hundreds of times as much energy as corresponds to the maximum accelerating voltage on the cyclotron chamber.